Hi, Rahul. We've been working on developing our the Dyno, which has been going through a lot of R&D activities, and it has come to a great shape. And many of our customers has also using that for educating the students today at their colleges and universities. I think I wanted to get some insights to people that what the Dyno is used for, and what all the tests that we can perform with the help of Dyno. So people will get an idea of what is Dyno and how it will be useful to study about doing a vehicle testing. I see that we have prepared a list of experiments that at a very basic level what we can do, and then any people who want to use it more, they can definitely use it more for many things. So just can you help us to run through what tests we can do, please?
Yes. So before slightly going there,
right?
So I just want to brief you on how a dynamometer is helpful in our vehicle test setups,
right?
And where exactly adds a value.
Okay.
So basically, if you want to measure a vehicle performance or a vehicle range as such, or anything, any measurements with respect to the vehicle,
right?
So that is where the dynamometer will come,
right?
So in case if you want to measure what is the maximum performance it is delivering,
right?
So nowadays with electric vehicles, there are different modes of operation, something like an eco mode and a sport mode.
Yes.
So with respect to different modes, we have to measure how exactly this vehicle is being performed.
Got it.
And what is the maximum performance? It is delivered.
Right.
And one more thing is that how much range it is providing.
Okay. Right.
So
very important.
Yes. So to actually measure this, not measuring this on the road in development stage can be quite tricky.
Absolutely.
And a lot of constraints will be there. It's as a prototype vehicle, like a lot of wires will be hanging out. So many issues will be there.
Yes.
So that is where this dynamometer comes in.
Right.
So what it exactly does is that one thing it's measures the performance of a vehicle.
Right.
Then it estimates the exact range by doing the road load simulations.
All right.
So that is what we have been working on recently.
Right.
That is also in a very good shape now.
Right.
So having that covered up, I think slowly we will move on to the experiments. So then we'll have much more in depth on what in all tests and the experiments that we use. And that will be run on the Dyno.
Just to give one more point, when you're mentioning that doing the prototyping, right? I think when you do it on the road, it becomes like it is not possible to repeat the same test cases, the same manner.
Exactly.
So, because if you tune something, you want to see a change, and if you take it on a road, you will not get to know, how is the impact of that changes into the vehicle, right? So, interesting. So, go ahead. I would like to hear more about it.
So, first we begin with the acceleration performance as well as the maximum speed validation.
Okay.
Right. So where we have, for different wide open throttle conditions as well as many other escape, right? So for different speed modes, that is eco mode, normal, right mode, sport mode,
right?
So we're able to simulate for different kind of payloads. Okay. That is one with only the rider, and one with the rider plus pillion. That is one person sitting behind the rider.
Okay.
So where if we estimate something around 75 kilograms of a
person's weight.
Right. So we consider around 2.54 overall vehicle weight. That is the GVW.
Okay.
Right? And for the rider and pillion, we consider around 300 kgs.
Right.
So for these conditions also, we can do it on the Dyno itself. So no need to put a person on behind.
Right.
So that same amount of load that is being acted upon can be used to. The Dyno can be used to apply this amount of.
Right. I think it's sometimes become tricky for people to understand that.
Yes.
How does a Dyno can apply a person's load onto the. I think we will pick up another topic another day where we talk about how it really applies the load. Oh, sure.
So that is a little bit tricky for many people to grasp.
Right.
But that is how, if you run the calculation, that is how it goes around.
Right.
So then we come on the road rate test. That is, what is the effect of the road rate? Suppose if you consider the flat road as a 0 degree of road grade,
right,
and a slightly inclined plane of around 7 degrees and 7 degrees,
right,
and also 14 degrees. That is the worst case. Usually they do it for all the tests.
Regulatory compliance test.
So here also we try to simulate for both the rider and the pillion
together.
together with the different modes.
Okay.
So that is what these test cases. So these amount to around 12 number of test cases. Or we compile them all together with all the different combinations and permutations. That is what we are at.
So if I understand that with the acceleration, we are trying to see if the vehicle can really be able to perform as in the same way with either rider plus pillion and such kind of scenarios. Here we are trying to also see that if the 7-degree gradient is there, if the 14-degree gradient is there, if there are one person, if there are two people, so whether the vehicle, how the vehicle will perform in terms of maybe gradient gradeability, also in terms of the acceleration. Also, I think we will see more about how maybe on the vehicle perspective, we want to study how much of current is being drawn, how much of the power of the motor is, how much the torque of the motor is able to produce, and all the extra right. So I think the dyno, we will measure that as a wheel torque, and then we can use the gear ratios and interpret the motor torque and other things.
Right, exactly.
Okay, sure.
So I do have one small report that I've done before.
Okay.
So I'll just run you through the different experiments.
Sure.
Then we can go on to the report, and we can discuss what are the results that we've got.
Right.
So apart from this, the other things we have is that the drive cycle simulation.
Right.
So if we come to our Indian standards, the AA standards, the CMVR regulates that.
Right.
It should pass the MIDC drive cycle, the modified Indian drive cycle.
Right.
So with that, in normal sport mod condition, we just use a rider as a payload.
Right.
And with particular track coefficient and many other iterations if possible. So that can be simulated.
Right.
So in that mode, we can tune the vehicle so that it can follow the drive cycle.
Correct.
So a person even need not sit on the vehicle and drive cycle.
Right.
Because human errors are a lot in this case.
That is true.
And a number of iterations to get a proper test will also be reduced.
Right. So I think I pick a point from there is that when you mean there is no driver sitting in the vehicle, that means we have a closed loop control to control the throttle. So our computational hardware would just take care of how much the throttle should be in the vehicle. So that's also a unique component in our dyno, which can do a closed loop control to drive the drive cycle test cases.
Exactly.
Right. It's right. Okay. Nice. So I also see another test cases as well.
Yes. So apart from the standard driving cycles, so the tester can take a real drive cycle.
Okay.
So it can log the particular data, and it can instead of doing it multiple times for different variations, you can just load that data into the the dyno, and the dyno is able to simulate
similar test cases. Right.
So that can also be done for for different eco mode, or if you have any other driving cycles which are taken from a different vehicle or different prototype aspect.
Right.
That you can test it with the different vehicle aspect.
Got it.
So that is the whole objective of these two experiments. That is, one is for the city and one is for the highway as well.
Interesting.
That is for both the different payload conditions, and the different speed mode conditions.
Okay. Right.
So now I think this is what major tests that are specifically done. So with these highway and city drive cycles, we are what we're trying to estimate is the range of the vehicle.
Right.
And what is the end consumption? That is the watt-hour per kilometer.
Got it.
Consumption.
Right.
So, and how it will affect in the highway condition with the pillion rider, and in the city condition with the pillion rider, or with the pillion without the pillion rider.
Right.
So all these cases. So for the previous experiment that we discussed, that is with the road grade effect and for the different performance. So I just have a small report.
Sure.
So I just want to run you through that.
All right.
So this was done for a vehicle with different speed modes.
Okay.
As well as different weight classes and all weight conditions.
Right.
So we'll quickly hop down and look at some of the graph that we have. Sure. So this is basically a vehicle velocity versus time for a different speed modes.
Got it. Right.
You can see the lower graphs. What you see here, these are for the eco modes.
Okay. Right. So that is somewhere like the yellow and the red ones.
Yes, yellow and the red ones. So these are for the yellow eco modes.
Okay.
And for the normal or the right mode, we can see there is a little bit increase in the vehicle speed.
Right.
Here it's only capturing the vehicle speed and the time.
Okay.
So and for sports mode, it is much more. So top speed it's going around 80 km/h.
Right.
and we can validate what is the maximum speed
Exactly.
a vehicle can go on.
With respect to each modes of operation. Right.
So if we come below, so what is the vehicle speed or the wheel speed?
Right. Right.
With the wheel speed, so necessarily it's not much of an required parameter. So we'll take a look at the motor speed.
Okay. Okay.
So this is the motor speed. So you can see the maximum motor speed because sport mode is going to 7,000.
Right. Right.
So that is a limit of this motor.
Right.
And how well is the motor performing?
Got it. Right.
So in this case, it's around 11 Newton meters of torque.
Okay.
That is produced by the
in the acceleration testing.
Yes.
Okay. Okay.
And for different modes, what is the maximum motor torque?
How they have limited the torque available with respect to each modes of the vehicle operations.
Yes.
Got it. Right.
So if we come down below, so what is the maximum power that is being produced?
Okay.
From the vehicle, that is
Right.
mechanical power, right?
Great.
So and for different modes, what is the
limited
power?
Okay.
So for eco mode, if you consider it's around 1,800 watts.
Right. Quite below, like I think 1C of the battery pack.
Yes.
Right. Right.
So if you consider like a normal mode or the right mode, so it's around 3 kilowatt.
Right. Right.
So it's around close to 1C.
1C as well.
So if we consider the sport mode,
Right.
so it's around 5.2 to 5.3 kilowatt.
Right.
So that is anywhere nearing to 2C of a battery usage.
Right.
So that is what we can estimate.
The amount of mechanical power it is produced at the wheel.
Yes.
Right. Exactly. Right.
So if we come down below, so there are a lot of other parameters. And this is one of the important parameters that we also consider for mapping the operating the characteristic of the motor as well as the vehicle itself.
Right.
So this is a graph where we have the motor torque in the y-axis, right, and the motor speed in the x-axis,
right,
where we can map different operating points of a motor,
right,
and at what speed, what is the torque it is delivering.
Got it.
Right. So this is we can see like for a different modes
the range, right,
how the operating modes are, operating points are lying on this graph. So and by this we can also tell that at around 4,000 Newton, 4,000 RPM of motor, we are able to extract the maximum level
Newton meter torque.
Yes.
Right. That's kind of a base speed range of the motor.
Yes.
Right.
Exactly.
Right.
Yes. So if you come down further as well, so we have it with respect to vehicle velocity as well. So at what speed we are expecting a maximum.
Right.
So that is with respect to different modes as well.
Interesting. So I think if you plot for the drive cycle as well, I think you'll see a lot of data points sitting everywhere across the right. And if you just overplot an efficiency of the motor, we get to see where the motor is operating with respect to its efficiency and gets us a more insightful data about the motor operating points. Right. Yes.
Right. So on top of that, if we have a counter plot of from the manufacturer,
right,
so we can easily plot that.
Just put the points across. Right.
And we can see what are the operating points like within the efficiency region which are operating outside the efficiency.
Right.
So all this can also be
right.
So this is respect to wheel speed and wheel torque. Okay. So this is very useful in terms of when we are trying to estimate or trying to calculate the gear ratio when it comes to a vehicle development stage.
Okay.
So as we are testing a market ready vehicle, so
they would have made sure that
Yes.
Right.
So if you come below, that is vehicle torque, wheel torque with respect to the vehicle velocity and many other things.
Right.
So so this is one more very important parameter where we plot power in the y-axis.
Okay.
So in the previous graph, it was the motor torque.
Right.
So now it is power.
Right.
And with respect to the motor speed. Here we can see the maximum power it is being achieved around 5,000 RPM.
5,000. Got it.
Motor speed. That is where the maximum power is being delivered.
Understood. Right.
And this is also changes with respect to
the modes of
different modes as well.
Got it. Right.
So with this, they with all this data, they can easily point out. So what is even the torque characteristic of a motor?
Right.
And where the constant torque or the constant power region comes at. Right. And where exactly at what particular power and what particular RPM, how exactly your motor or the vehicle is delivering the power. the power delivery, all these things, we are able to.
Yes. Right.
So this is one of the report
Compiled.
So
Right.
it has a lot of other insights as well.
Right. Right. I think that's a good discussion point for the future things in place. I mean, I'm glad we are able to compile the report. I think when you talk verbally about all of this, it doesn't really come into the people's head. But I think with the report, one case study is going to really open up. Oh, I can now take an any vehicle and then I can do the same test.
Yes.
I think now with all those test cases we have discussed, like drive cycles and then the acceleration, gradeability, and all of that, if somebody does all of this thing, they really will understand how the vehicle characteristics are and how the motor characteristics are, how the vehicle is behaving. I think a lot of insightful data that they will be able to gain as a part of it. It's great. I think that's a good summary to close it up. I think maybe it's kind of a tech bite of Dyno and tech bite of vehicle testing in place in today. Thank you, Ron.
Thank you.
Thank you. Thank you.